Hello, everyone. We'll finally start. My name is Mohammed. I work for Property Finder, and my wife is watching us today, so if I make mistakes, please don't tell. Okay? I thought about making this presentation because many people think about machine learning a lot more than it actually is, and it will be very easy for us to understand a lot of concepts without having any technical or mathematical background. So if any one of you have a math phobia, no scary maths for today. So this is my family, and I've studied in Alexandria University in Egypt, and then studied in the UK later on. And if you want to look at my profile, you can look at LinkedIn. It doesn't matter, but if you notice here, every turn is a career change. So I've had some career changes that will be like more than the average person's. And before we talk about AI, let's have a quiz. So the quiz is written on the whiteboard. Can you guess when was the first self-driving car experiment conducted? 2005, 1995, 1925, 1975. Any guesses? Any guesses? 25. 1925. And most of the successful projects that we have today are not from this century, have been thought of a lot of time before. And if you're familiar with AI from before, there's something called AI winter, where a lot of projects have started and then funding cut. So we'll talk about this in a bit later. And this is the first part of the presentation, and this is the second part of the presentation. So if you don't like maths, you'll find this interesting. If you don't like hype, you'll find math interesting. I hope you will like both of them. So before we start, we need to define what is AI. So artificial is easy to define. It's like the science and engineering of making intelligent machines or intelligent computer programs. But intelligence is a tricky bit. And to be honest, I don't know of any complete definition of intelligence. So intelligence might be defined as the computational part of achieving goals in the world. It might be defined as the knowledge, imagination, understanding, problem solving, a lot of traits, but no complete definition. And in machine learning, we try to mimic intelligence in a way that machines can execute, and it's not necessarily related to biological intelligence. So most of the machine learning tools that we are using are inspired from biological intelligence, but it is not necessarily the case, as we will see further. So how did machine learning emerge? So machine learning is inspired by how the brain works. So there were many theories about cognition and how brain works in general, but this is the theory that stick, and this is the direct application of machine learning. So a connectionist model is the way our brain works, or the way our brain cells operate, by representing any mental phenomena as a number or a vector or an activation. And this activation can be interconnected through a neural network. So a neuron is a brain cell, and it's also the same term is coined and borrowed to the machine learning neural network that you see on the right. So learning and memory is established by the connections, those connections, and we will see that in details later on. So what is machine learning? Again, machine learning is the algorithms that computer systems use to perform a specific task without using instructions, explicit instructions. So any one of you is coding or software developer? So if you've done any coding before, you give the computer instructions to do a task. The computer cannot do any more than the instructions that was written on your program, and it takes the data, you take the data, write your software or the instructions, and make sure that it works in many cases, or a lot of cases. If an edge case emerges, you have to rewrite the program or update your program to accommodate for that edge cases. Otherwise, it will not work as expected. So that is programming. A program sometimes is called an algorithm. you give it data, and you give it a set of instructions or code, and then you observe the expected output. And hopefully this output is as you wish, or as you desired. In machine learning, we still have a program. So a machine learning model is still a program, but it doesn't have explicit instructions to solve the problem. It has instructions to learn something interesting from the data and use it to solve the problem, or to output something like a program. Hopefully we don't do that all the time. So it's like sometimes machine learning doesn't really work, and we have to like iterate and do more work on it. But this is not always the case, I hope. So what did people do before machine learning? A lot of data problems have been worked on and developed way before machine learning. Some of them used AI, other branches of AI. Some of them didn't. So usually we use statistics or statistical properties of the data. We use pattern recognition, which is finding a structure within the data. We use the geometric properties of the data, and we use signal processing for some data like audio. Sometimes we combine one or more of those, and I guess there are many other ways to solve a problem. So hopefully this is not the statistics that I'm talking about, but statistics are very important in order to operate and understand machine learning. So before machine learning, there were spam detectors on any email provider. And one way to go with spam detection is to look at the subject line. What is the likelihood of a subject line containing a specific word, like congratulations, to be a spam? From the history, you can build a statistical model or counting numbers. This is a spam and this is not a spam, and you can build a program that will detect spam, but it will not be very successful. It will have a cap on the accuracy. So let's go to face detection software that was developed in 1973, one of the like breakthroughs or pioneering software in that field. This is the year of 1973, and this is a scientist, Kanade, who developed this software, and he also has a lot of pioneering work in computer vision. So in that time, scanning wasn't very simple as it is now. So the pipeline, that is only a part of the pipeline, is getting the original image, digitize it, and create something called a binary image, which only includes the features that are relevant to the face detection problem. So he kind of removes everything else that doesn't matter to the problem. And then the final output will be those points that are, those key points that are interleaved on the face. So the program works sequentially. First, you try to detect a pattern of the face, like the face head, and then eyes and nose and so on. And it has some way to reiterate or to correct itself. But the accuracy of that program did not exceed 70%, and it was only developed in like a very small data set. By small, I mean less than 100 different faces. And this is only part of the pipeline. It can fill the entire room. Then let's try to learn a little bit more about machine learning. So machine learning could be considered as a function approximation. So let's take the face detection example. There is a function out there that can take the image as an input and output yes or no if the image has a face or doesn't have a face. And basically, machine learning is a search problem. It searches in the function space or a lot of functions to try to find this function or an approximation of this function in a smart way. So we have examples, like in this instance faces, and we have a machine learning model that tries to use induction, which is creating a function approximation, and then uses that function in unseen data or new faces and try to validate if that image is a face or no. And we call the induction process or the machine learning models that use induction model-based. However, there is an easier problem, and sometimes it is the only possible solution to problems. which is we don't try to find the function. We go directly from examples to try to find the values of the unseen data. And this is called transduction. So for example, in machine translation, in Google Translation, we don't have a way to create a function to understand the entire vocabulary or the entire structure of English. So what we do is we have millions of different examples that have been developed in a way that we can learn from those examples how to translate new sentences or new structures of languages into other languages. And we can repeat this process into different language pairs. We also touch on reinforcement learning later on. And reinforcement learning could be conceived as one step further in human cognition. So instead of learning to optimize a pattern or to optimize learning problem, we learn to optimize rewards. So like a small child learns from being rewarded or being punished. If you remember in your childhood, sometimes if you fall down, you might have remembered that event until today. That is a very powerful way of learning. And if we look at inside any machine learning model, or how a machine learning model works, it starts with an objective. So we have an objective to accomplish. And this objective, our objective function, tells us how good our model is. So for example, if we have a face detection problem, our objective is to maximize our chances or our luck to detect faces. And usually statistics is a fancy name of modeling luck. But an objective could be a bit general, and it could be a bit like difficult to optimize. So we derive a cost or a loss function from that objective in order to optimize it and find a way to generalize or to make that model work well on unseen data. Usually optimization works better on minimizing stuff. That's why even if our objective function is maximizing a value, we use a loss function to minimize another value, typically the negative of that value. Then how to evaluate a model? We evaluate a model in some data set. And this model evaluation tells us how good that data set. The simplest way to evaluate a model is accuracy. So how many right guesses we have. However, this is model optimization, sorry. So I'm going to get back a little bit to touch more on model optimization. This is kind of an error or cost trajectory. And it is a 3D. It might be a little bit difficult to visualize, but it is just like a mountain or like a hill. So our objective is to use calculus to go from a high point, usually a high error rate here, into a low point there. And if we reach that low point here, hopefully our model will generalize. So how do we do that? It's like skiing. So we take one step at a time with the data set, and we go closer from here to there. And getting back to model evaluation, imagine this data set is a rare disease, and it's only available in 1% of the cases. So if we cheat, if we would like to cheat and output a model that doesn't learn anything and says no disease all the time, we will be right 99% of the time. And this is, of course, doesn't work. So accuracy could be a good evaluation metric in some models, but it is not in other cases. Usually we have to consider something called false positive rate and false negative rate. We will touch on that later on. So now there are several types of learning, and we mentioned supervised learning in an earlier slide. So supervised learning is when we have labels on the data. So we have an input data set, and we have a human to label that data set, or any other way, or an expert to label that data set and feed it to the model. So if you would like to train a classifier to distinguish between cats and dogs, or cats and no cats, we just make labels of this is cat, and this is no cat, and this is cat, and so on. And then the model uses the optimization method to learn, and hopefully it will predict the unseen or the new cats and dogs images correctly. Then someone does this as a model, and it blows up. So usually it is not always easy to apply machine learning models on unseen data. And that is what counts. If we have a model that works very well on the data that we feed it, it is memorizing the data. It's not actually learning. And this is called overfitting. So the way to evaluate a model is on data that it didn't see before. And sometimes we don't really need labels, or labeling is expensive, or we are trying to explore the data before we decide to have a budget or spend on labeling them. So that is unsupervised learning. So if we have the same cats and dogs example from before, at least the model can try to identify cats and dogs as two groups. Example of this is how we use pickup locations on Careem rides. So if you use Careem or Uber, you would see that once you order your taxi, you will have few or three different locations and usually your pin will dock in one of them, because it is easier. Sometimes it's a bit difficult to find a pickup point, or sometimes the difficult point is to meet with the driver. So how do we do that? We tell the model that we have 3 clusters of data. So the model doesn't learn that. We tell it that we have 3 clusters of data, and then also through optimization, we try to find the centers of those 3 clusters. And those centers are the ones that you see here. So getting back to the classifier problem, or the cats and dogs problem, one way to learn about cats and dogs is to learn how to draw cats and how to draw dogs. And then if we learn how to draw, it is an easier problem to learn how to identify. So this is called generative modeling. And in some problems, generative models are the only solution. However, most of the time, we only learn how to distinguish between cats and dogs, and this is called discriminative modeling. Discriminative means we are only interested in this line, this red line, and it is like the border or the decision boundary between cats and dogs. Also, sometimes machine learning doesn't need to learn only classes of data. It can learn values as well. So when you order Careem again, you have an estimate of the cost of your ride, and this is done through regression. Regression means fitting a line or fitting a polynomial, like a curve, into data. And we do this also iteratively by minimizing the error between that line and every data point. So it ends up like getting very close to each data point of them, assuming that the relationship between the data is linear. And we can apply more, if we understand the single dimension case, we can apply it to more dimensions or more complex data. So now we understand a little bit about machine learning, and let's go to neural networks. So a neural network is a mapping of how the brain works. So a perceptron, which is the term that was invented in 1950-something or 40-something, is is an approximation or a simplification of the human brain cell. How does it work? It takes input and then tries to sum those inputs and pass it to an activation. So a human brain cell activates in a certain condition, and each cell learns how to activate differently, and that is how our memories and how our emotions and thoughts are stored or are processed. So this is the same concept with a lot of simplification, and those weights control the magnitude of each input or the influence of each input on the activation. So if the first input is not important, then that weight will be very small. If the last input is more important, then the weight will be a little bit higher. And what we try to learn is those weights. So if we try to learn handwritten digits, which is a very basic and popular example that you can follow, let's assume that we get a data that is cleaned, and the images are fixed size, and every image is just 28 by 28 pixels. So the image size is 784 pixels. And this means if we try to input the image into the neural network, we would need 784 neurons to get that input. And our job is to take those 784 neurons inputs and train the network and reduce the output into only 10 possibilities, which are the 10 digits from 0 to 9. So how do we do that? The objective, or a good model, will learn how to every neuron of those is activated, and the activations will be the highest on 9 on the 9th neuron on the output. So why do we need hidden layers? Hidden layers are, think about it like an abstraction. So if that 9 digit is written that way, a hidden layer the first layer learns smaller level of abstraction of the data, so it can learn how that curve is written and how this line in the bottom is written, and so on. The next layer learns a little bit higher level of abstraction, so it might learn that this is a circle and this is a line. And sometimes that circle is shared with other digits as well. So learning from those layers usually takes a lot more than 2 layers, and we call them hidden layers because we don't really observe or concern about their outputs. So we only feed the model the input, which is the data, and we expect some output from it. And what's inside is for the model to learn. So those are examples of the previous activations. When I train this model for a few times, you will not be able to distinguish meaningful characters or meaningful digits from it, but you can see the patterns are started to develop. And if you train the model more, you will have more granular patterns. Another way is try to understand that the pixels of an image are related to each other. So for example, my face has the same color gradient, or almost the same color. So most of the pixels of my face, if I put it in an image, would be of the same intensity or would be of the same color, except for the borders and except for the eyes and so on. So in order to mimic that or to leverage that, we try to act like the human visual cortex or the biological visual cortex, not necessarily human, by looking at a part or a region of the input image. So here, each region is a few pixels, and then those filters operate like receptive field, similar to what our eyes work, how our eyes work. Then we use many of those filters, and then we try to reduce the problem to a smaller number of neurons at the end, and then feed it to the final output, which is similar to the previous example. And this is called convolutional neural network. It is very well suited to more complex vision problems because distinguishing digits is a very trivial problem. Usually the problems of classifications are much more complex. And an example of a generative model, which we touched on earlier, is generative adversarial networks. So generative adversarial networks are used in many applications. Some of them we'll see later. And they consist of 2 networks working against each other. So a generator is trying to generate fake copies or fake replicas of the input images. And the discriminator is trying to distinguish between the fake ones and the real ones. and we keep on training that network until the discriminator is helpless. Helpless means it cannot distinguish anymore between the fakes and the reals. We will see a very interesting application in a few slides. Now, the final bit of theory, I hope you're still alive, is reinforcement learning. Reinforcement learning is reward optimization. So what we've seen previously is pattern optimization, or supervised or unsupervised learning. We still need to find something in the data. But here, we need to find a policy in an environment. And an agent, which is like a software agent, is trying to take actions on those environment like this. Actions gets rewards and observations, and then try to learn to maximize the cumulative rewards, or to find the best policy. That is very common in games, like if you've heard about AlphaZero, which have beaten the world champion of Go, which was a very difficult game in the past. And there are many other applications in robotics and industry and so on. So this is an example. Agents could be a robot. If it goes to fire, it will get pain. Pain is attributed by negative reward, and then it will learn how not to go to fire again. So here, think about reinforcement learning like if you're going to study in a med school and you only take exams. Every day you take exams. You only view the results without answers or without explanations. And you try to learn from exams only. So let's see an example. So reference means the agent on the left is trying to learn the actions of the agent on the right. And here, they compare different solutions, and so if you see it is failing because it's only trying to not to fall, but it's not trying to learn how to flip. So this is the left part, the theory part. Let's move to the drum part, or the high part. There are many use cases of machine learning, and we use it on many applications that we interact with every day. So we are familiar with most of those: product recommendation, face tagging, fraud detection, language, sentiment analysis. Like companies want to know how you perceive their products. Do you think their products are good or not good? And there is a lot of data that is being collected and being analyzed about us, even more than we can imagine. So we'll take motion tracking as an example because I don't think many of us is familiar with. And this is 2016 technology. So it can follow you on different parts in a feed. You see that the detection is here. There is also a lot of research in machine learning, and some of that is still, it has a lot of time to develop, still immature. And we'll talk about ways to move towards the general intelligence, because many people think that machine learning programs can understand the data, but this is not the case. It is a program like any other program. It applies the AI methodologies on the data, but it doesn't actually understand what a face looks like or what a digit means. But here, in improvisation learning and social machine learning, we are trying to move a bit closer to how humans operate and think. And we will try here in improvisational learning to relax the assumption that world is predictable, goals are fixed. In all the previous examples, we are trying to optimize toward a fixed goal. So the machine learning model does not learn the goal, we provide it to them. But here, we assume that the world doesn't have a fixed goal, and we try to find a way to even learn that goal. And there is a lot of applications in medical research, so we will touch on one of them, cancer detection. And this is a breast cancer detection machine learning model. Some of the breast cancer cases cannot be detected with a normal screening process, so it has to go through something called mammogram. And this mammogram is a bit difficult to distinguish because it requires sometimes two radiologists to have a final opinion about it. So this model is combining the partial or local regions that we saw on the convolution network example from before with learning from the entire picture and combine them in one model, in one pipeline. And it is exceeding the human radiologist quality. So let's see some funny applications. So this is an application of GAN, Generative Adversarial Networks. So any designers in the room?
Wouldn't it be great if everybody could be an artist? If we could take our ideas and turn them into compelling images? This technology allows us to create a smart paintbrush so that if you wanted to create a new picture, you can just draw the shapes of the objects that you want. And the neural network can then fill in all the details. If we add a water feature, the network is able to add reflections, not because we told it that, but because it learned it. Or if we change the ground to be covered in snow, then it knows that the sky also needs to be a different color. I really think this technology is going to be great for architects, designers, people making virtual worlds to train robots and self-driving cars. The input to this model is something we call a segmentation map. It's like a coloring book picture that describes, here's where a tree is, here's where the sky is, here's where the ground is, and it doesn't have any details.
It works also with shoes. If anyone interested, you can draw your best perfect shoes, and it will try to match it with real shoes from e-commerce websites. Here is another example. Can you see this face? If you have internet on your phones, you can go to this person does not exist, and it will generate a new face for you. And those faces are not real. So this person is not real. It is an application of GANs. And also this person, imagine this perfect woman who, the model is perfect, but it didn't match her earrings together. So it's still not perfect, or it still doesn't understand how to generate faces. It only learns by optimization. So there is a part of AI called common sense reasoning, and this is something that also scientists are working on. And if you like art, you can blend your photo with a pattern, and you can get this. And you can play around. There is a website on it. You can play around, and you can have different patterns, and you can have very artistic photos of your face. And this is the interesting part because I've generated this music. So let's play music while I speak. So I'm not a musician, and I don't know much about music, but I managed to use machine learning software to generate this music. So it works like I select genre, I select a few highlights of the music, percussions and notes and so on, and it uses it to generate very realistic music. And this is like a more happy version. And there is also lyrics generator. So you can find a way to generate music and generate lyrics and put them together and find someone to sing. There's also a few bad applications of machine learning, and it is getting like some way less control, or out of control, I would say. And let's look at this before I explain it. So if you're familiar with The Shining, the movie from Jack Nicholson, this is Jim Carrey's face on Jack Nicholson. Let me maximize it. It is very real. It is very difficult to distinguish for So this is called deepfake, and Facebook is sponsoring a Kaggle competition, and is giving away $1 million reward to the best model that can detect deepfakes. So it's a very serious problem. Sorry. This is another example of like fooling or cheating on a machine learning model. So the model was trained to detect persons, and this is the output of the left. And without touching the data or the model, that person managed to make themselves undetectable by putting this patch on his body. It's like an image with people with umbrella and some noise added to it. And the model completely missed it. So it didn't detect them. And this is also an attack on stop signs, which are very important for self-driving cars. And here, if you notice, there is some noise on those spots. And that sign is detected as a turn right sign. So getting back to self-driving cars, the funding for self-driving cars was cut on 1970. And I think if it wasn't, we would have had self-driving cars as we speak. So hype. I think most of you came here because of the hype of around machine learning. So this is a Gartner hype page from 2019, or the hype chart of 2019. And it looks like machine learning is falling off the peaks of inflation, peak of inflated expectations cycle, and is going through the next cycle, which means it is getting out of hype. Sorry? Yes, it is here. So here means 2 to 5 years until plateau. Plateau means like steady development, like email, for example. We don't have many innovations on email systems. So machine learning in 2018, by the end of 2018, it was here at the top. But now it is falling off here. However, this might change because in the Middle East, we are in a different stage. Not only in the Middle East, the entire world is behind the big 4 companies, Google, Amazon, Facebook, and Apple. Those companies have more data than anyone else, and a model without data does not worth much because the model learns from data. If you don't have data, then you can have the best model from GitHub or from the internet, and then there was nothing much to do with it. And let's have also this example. Can you hear?
Sure. What time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15.
So the left hand is a bot, it's not real. And it's managing the entire conversation line.
Service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have at 10 o'clock. 10 a.m. is fine. Okay, what's your first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
So if you see, the voice is very realistic. Let's see the next call.
Hi, I'd like to visit people for Wednesday, the 7th.
For 7 people?
It's for 4 people.
4 people with
Next Wednesday at 6 p.m.
actually we need to for like after like 5 people for people you can come
How long is the wait usually to be seated?
when tomorrow or weekday or
For next Wednesday, the 7th.
no it's not too busy. You can come okay.
Oh, I gotcha. Thanks.
So that is completely AI. Yeah, and that is from 2018. It's not like this year, but it wasn't really rolled out throughout the world yet. And also, if you notice, that was a live demo in Google I/O, the biggest event of the year for Google, and they did not inform the other party, which is a human, that they are going to record that call. So they still have some privacy issues. Many people wrote about it, but so they had to fix it later on. But privacy is also a very concerning issue with machine learning, or what's next on machine learning. Also, there is a lot of advances and a lot of hype, but we don't really touch machine learning outside the use of social media and our interaction with big companies. So our healthcare provider, I don't think they're using machine learning that much, even in the US. I'm not talking about Middle East only. Quantum computing, if you've heard of Google quantum supremacy promise, which is they claim to have 10,000 years worth of operation in only 200 seconds with a quantum computer they designed. That is a huge leap for computing in general, and machine learning will also benefit from that. Why? Because machine learning is 7 times faster than Moore's law, which means the compute power of machine learning models is doubling every 3.5 months. Moore's law indicates that the hardware chip power is doubling almost every 2 years. And it's been the case since Moore is one of the founders or one of the early CEOs of Intel who coined that theory, and it's been the case until now. Some people debate it, but it is almost the case until now. So the advances in compute power are huge for machine learning. And I finished this presentation, then I found this Neon, which is a product from Samsung. I'm not quite sure how it works or what it does exactly, but they claim to be the first artificial human. Artificial human means they are trying to distinguish that product from virtual assistant like Siri or Google Assistant. And it does have its own brain, its own character. It learns from interactions with us. However, I don't think it has general intelligence yet. So it is designed to have a specific purpose, like yoga instructor, like doctor assistant, for example. And when they showcased it in CES, which was a big event in Las Vegas, I don't think it matches the expectations. Let's see.
Leon, what's your favorite food? Leon, what's your favorite food? Pizza. Leon, what do you want? What do you hope to accomplish? Leon, what do you want? What do you hope to accomplish?
now it doesn't have a response.
My neurons are burning just thinking about that.
So they claim that they have developed something like a new technology, and they call it Spectra, and another technology called Core R3. Core R3 is like machine learning on steroids. I don't think it's a new thing, but it is. They claim to be real-time responsive and so on. But Spectra is the emotional part of that product, and they are working on it. I don't think it is also ready, but they wanted to be the first. So they wanted to create some kind of a hype. So if you go back to the hype cycle, so I'm not sure if we are going to be full of, or maybe there are something like AI developer toolkits or something in that range, smart robotics, that will move up here soon. And usually a hype cycle is for any kind of technology. It's not only for machine learning. Machine learning have been out of favor, or AI in general have been out of favor for many decades. So during the 50s up to very recently, many projects have been cut and many fundings have been like disappeared from machine learning. And the advances of machine learning before the big companies was due to military purposes and was done by governments. But now it's not the game anymore. Like the big companies are controlling the machine learning worlds, and every one of them is having a research center. So Facebook and Google and Samsung, all of them have research centers that are pushing the state of the art or pushing the machine learning to the next level. Thank you very much. So questions?
Do you have any examples from UAE or Middle East where some good AI work has been done?
We do a lot of machine learning in Property Finder, but I didn't prepare something to showcase here because that wasn't about my company. It was about general introduction. But we have examples to optimize the images that we display on our listings, for example. We have examples to optimize the customer journey and to optimize our agents and make sure that they are not going to leave us for any reason. So we have a lot of predictive examples or predictive modeling to make us more optimized in our business. But the research part is not something that companies or commercials focus on. So what I showed here was mostly mix of both, research and commercial part.
Can you share some examples what you did for your company?
Sure.
And how much did your sales increase or revenue increase?
We can have a KPI, and we can attach a dollar value to any machine learning model, because we can do something like called incrementality analysis. So we can have a scenario where there was no machine learning model involved, and this scenario, we know the output. And then after machine learning, the output is different. So we can find the incremental effect of applying machine learning or applying predictive analysis in general to a specific problem. So for example, if you have like paying clients, and those clients are subscribers, they have recurring payment for your service. So you can predict how many of them are going to leave you on the next paying cycle, and you can do something some interventive measures to try to restore or try to prevent the loss of some of the clients that you are expecting them to leave. And you need to compare historical data with the future data. So it's not going to be an exact measure, but it will have a very robust value attached to the model that you are developing. And you can even feed back that result back to the model and improve it. I hope this answers your question. Sure.
So I just want to know, what is when you talk about unsupervised machine learning, what is the format of the data?
The format of the data,
It's technically unlabeled, but how do we segregate the data? Technically, when we go for machine
Yes.
And then but how do we define it when the data is completely unlabeled?
Okay, machine learning or computers understand numbers. So first you need to make sure that the data that you are providing is numeric. So for example, if you have images, the image data is by default digitized or numeric, right? But there is no much difference between supervised and unsupervised learning, except that you don't have labels on unsupervised. So the format is the same, like any other machine learning model. But the model itself is different.
Okay, so technically it uses clustering or
Clustering, exactly. One of the very obvious examples is clustering. Sure.
And you mentioned that you uncovered while you use machine learning.
Yes.
You didn't mention that you use it for recommending a product to the user, or where do you use that? How do you use machine learning?
We use machine learning for recommendations, for image quality, for predicting many measures internal measures in our business, and for automated marketing to predict the output or the success of marketing campaigns. There are many use cases that we use machine learning on. And we work as a team. I don't know everything, but those are examples of what we use.
In connection with her question,
Sure.
so for this property finder, will I be able to, the property finder can predict from the end user point of view,
Yeah.
say, I have my budget of 50,000 AED,
Yeah.
and I want a home, say, 2 BHK.
Yeah.
Right? Will it be able to predict and tell me, okay, so and so, wait for 2 months, and you are going to get a property in this range, in this area, based on your models? Will that be sort of your prediction? Not on the sales part, that's all analytics to be very honest with you.
Okay.
Right. On this, from the end user point of view to him to experience, okay, there is
Yeah.
going to be a place which is going to be available in 2 months of time within this budget, within my expectation. Will it be possible?
Okay. The way we operate is we list properties, and we also have a valuation model to help you estimate the value of that property if you are going to sell it or rent it. And this model is going to be released very soon. But I'm not sure if we are going to be able to tell you what will happen in the future. Because valuation or understanding the value now is completely different from understanding the value a few months later, right? And maybe we have this in the making, but maybe we don't. We're not going to offer it now for end users. Maybe we'll offer it first to banks or investment parties or any corporate use case, and then when it succeeds, we offer it to the users. So I'm not quite sure if we have this ready yet, but we are working in a valuation model. Part of valuation, of course, is the future or appreciation of a property. You're most welcome.
Question about the future.
Sure.
So it's expected that in the future we will spend more time understanding why the machine or the device is something,
Yes.
rather than making this algorithm or predicting this.
Yeah.
Outcome, okay, we get the outcome, why is there?
There is a lot of research taking place on explainable machine learning. Is that what you're referring to?
Yeah.
Like, for example, if I am in another country where a bank has to provide reasons why they approved or refused to offer you a facility, a mortgage, for example, then explainable machine learning has to play a role in this, because a bank will not be able to use it without providing reasons. And we also, any machine learning model can leverage weights, and those weights can have some kind of correlation with the real reasons. However, correlation is different from reasoning or from causation. So that is an active area of research. We know some parts of it, but we don't know the entire picture. And some models will be optimized for that purpose. Sure.
There are some data analysis solutions in the market, right? And they usually claim they have some kind of machine learning feature.
Every cloud offering has machine learning, of course, yeah.
From your experience, does it really work? And if it does, do you have any recommendations?
It depends on the use case. Google Cloud Platform has better or maybe more interesting models for language. Amazon maybe have more interesting models for vision, but it depends on your problem. Usually, when we have a complex problem, we don't start from scratch. We have a model that is almost ready, or we call it pre-trained, and then we fine-tune it. We train the final bit of the model to the problem that we are trying to solve. So you don't start from, you have to start from a point where others ended. Sometimes having a model off the box or off the shelf works well, and some other times it will be not very useful.
Do you have experience with Data IQ?
No, not really. No, most work.
What is the technical stack that you use for like creating model and working on models? Technical environment.
Technical stack is mostly Python. Sometimes we use Keras, sometimes we use PyTorch. Those are machine learning frameworks, and it depends on the problem as well. We don't really have to stick with a specific tech stack, but Python is like the most popular language for machine learning now.
Just a follow-up question, like.
Yeah, sure. I just have your thought.
Popular libraries you can use for building chatbots.
You can start having a chatbot first on a cloud platform to understand if it will add value to your business, and you can even have a free tier Amazon AWS account and try to use a chatbot on it, because chatbot development in AWS or even IBM platform is very simple. You just try to define few scenarios, few intents, and see how it works. But I didn't work on chatbots that much, so I don't know if there is a platform. I'm sure there is, but I don't know any one of them. Sure.
I think it's a common notion that Python is the best for machine learning. Is there any other alternatives, and why is Python the preferred one?
Because Google has released many tools that work on Python. Facebook also have released many tools that work on Python. There are many other languages like Julia, for example. However, you need to have community adoption. And sometimes you have to keep an eye on a tool, because it might be like picking up very soon. For me, I try to keep up, but it's very difficult to keep up with everything, because the field is changing very quickly. I would say Julia might be a good language, or might be a good candidate to keep an eye on. You can look at GitHub and how many repos are developed in this language to have like a sense of how popular it is or how it will pick up soon. Sure.
Did you want to cover this, the intrinsic difference between machine learning and artificial intelligence? What would be the differentiating factor?
Machine learning is only a part of artificial intelligence. So pattern recognition is artificial intelligence. Search is artificial intelligence. We use search since like 100 years ago. Not specifically for web search, but this is how IBM Deep Blue have won the world chess championship in 1997. It was just a search algorithm, and that is AI as well. So machine learning is about learning from examples or from experience, and that is like a small part of AI. I think your question is, what is the difference between AI and general intelligence? General intelligence is creating a computer system that thinks and acts like a human and has judgment like a human. We are not there yet. So AI is narrow intelligence. Sure. Yes. Yes.
What are the other dimensions that have been added to the machine learning that makes that possible?
You train the machine learning on a lot of voice conversations. So first, you have the problem of speech to text, which is solved already. We have speech to text systems on Siri and many other platforms. Then you have the problem of understanding intent, or language understanding in general. Understanding does not mean being aware. Awareness is a different level. Understanding means I understand that the opposite of high is low. That is a kind of understanding. And you have to develop metrics to optimize for the specific data set that you have, which has a lot of phone conversations of the same purpose. So this example can work with booking a salon, but it will never work if you tell it to give you examples of the weather, for example. or ask it a general question. It is optimized for a specific purpose. It doesn't understand above and beyond that purpose.
It seems like it's very tailored for that one specific task. Like
Yes.
Flavin Google's quantum computing is like they proved it.
Yes.
It's tailored for one specific function. It's not possible to replicate. I mean, not replicate, but use it in other situations, right?
Quantum computing is a different case because it should be a general purpose computer. However, a machine learning model, as of now, is not meant to be generalized. There is research on that, like model of models, like fusing different models together, but a specific machine learning model is designed for a specific goal. And that specific goal could be a bit general, but it's still like within a framework.
So can we say that chatbot is nothing but a group of FAQs? No?
Okay, you know ELIZA? That is a very historical system. A Turing test was the reason behind developing ELIZA, and many people still believed that it is a real person. So most of the AI problems or most of the machine learning problems have history and have solutions behind or without machine learning. So I don't think it is only a set of FAQs, because we now can have language understanding. Before, a set of FAQs is not about understanding a language. It's about trying to maximize our chances, our luck. So that is one step ahead. Besides, a set of FAQs will be hard-coded or will be specific instructions, like computer program, and a machine learning will learn from data, from previous data, and apply your scenarios of chatbot to the data that it's already learned from.
What limitation do you see with R for machine learning? For R programming?
For R, I'm not very familiar with R. I used it like more than a year ago. A machine learning program or a machine learning model without having building on top of an existing model will be a bit limited. So if you have a library or if you have a set of modules similar to what PyTorch can offer or what TensorFlow can offer in R, then you have a lot of possibilities. Otherwise, you have to code everything from scratch, and this is not a really good advice to do. Sure.
Going to that McKinsey report, the impact of AI and automation on the industry.
Yes.
Right now, you can just put a line because the stop sign is giving us a wrong indication. That means still the accuracy is very much low. It's not like 6.
No, that's a specific attack case. That's an attack.
Well, like which industry is impacting a lot right now? Like health and insurance, or like telecom, automation. If you can put a light on all this.
Okay, there are things that we know about how companies operate, and things that are happening behind the scenes that we don't know much about. So, any information, any IT-based companies or any information system would have some AI or some machine learning behind. So even your email, your social media, and like Careem and Uber and all those. However, if we move a little bit upward to an industry level, there is a lot of technologies that are very emerging and very ahead, but the adoption of the industry is a question, because industries move on their own pace with their own interests. So pharma, for example, like medical companies, they try to maximize their profits. They don't try to maximize the number of people who are disease-free, because that's not good for the business. Sure.
I have a question. I'm not sure if you have the answer, but back to your point where you said it's hype right now, machine learning, right? It's a great time to start a chatbot business. And I had discussions with multiple of them, and you don't know actually how to price the service, okay? Because most of them will use IBM Watson,
Yes.
Facebook NLP or Google NLP, right?
Yes.
And me as a client will give them the scenarios for the intents and the patterns of discussion with the customer, right?
Yes.
And then they will tell you, okay, we'll charge you 100,000 dirhams per year to just build that part for you. So do you have any idea how to value that work that they do?
So if I understand you correctly, you are trying to get a vendor to develop a chatbot for you. Okay. First, do you have any technical person in your team? Okay. It is not very difficult to learn how to develop a chatbot in IBM Watson. And you can create a free account and see if you can do it, even with very limited capabilities. I would say if this takes more than 20 hours of work to get a minimum product, I wouldn't say like a fully functional product, then it's a difficult problem, and then you have to go to a vendor and see how they will charge you. But I don't think it's worth that amount of money.
But there's a lot of companies like it's Dewa, Salat, all companies are buying chatbots now, and that price is not that much actually. It's even more than that. So there's no companies don't know how to price these services.
I'm not sure if they don't know, but I think since that technology is not very common, so they have a leverage, or they have a premium to charge. So the amount of work is not proportional to the value that you provide, but for anything. That doesn't apply on a chatbot, it applies on anything. So I would try to find some people overseas, like on Upwork or any other platform like that, and I would try to make a proof of concept first before I go to a full solution and see how it works. No problem. Any more questions?
So, models can be quite racist as well. They can be prejudiced. For example, they can be prejudiced against women. In the insurance business,
Yes.
a real human would charge more premium to women, and machine learning model would actually try to mimic the human, and model would do the same thing. So, in case of human, we know who to blame.
Yes.
But in case of models, we blame them for racism and all this.
That's a really interesting question. There is a lot of articles published about bias in machine learning. Machine learning models are having less accuracy of detecting people of color's faces. If you are not from a Caucasian ethnicity, the chances of a model to identify you or to re-identify you are much less. It depends on the data, and you have to encode or to account for bias in the model that you're developing. So if a company is willing to do that, they will find ways to do it. But otherwise, the model does not generalize more than the data that you provide. Let's put it this way. Yes, exactly. That's a very good answer. Sure.
With respect to how your team is structured at Company Finder,
Yes.
in terms of ratio of data scientists to actual developers, how is that set up?
We have data science team, we have data engineering team, we have business intelligence team,
Yeah.
and we have core team. And I don't know most of them.
You don't?
I only know the data science, business intelligence, business intelligence and data engineering. The ratio of ex-developers to a data scientist is not a very useful measure now, because you can find easy ways to productionize whatever model that you are working on. It's not like before that you need to have crystal clear standards of coding. I used to be a software engineer, but not anymore. I don't claim that my coding quality is similar to a software engineer. And I don't have to, right? Because at the end, we have more compute power now, and we have more ready-to-use models. We build on top of that.
So in terms of when you're using, are you directly using Python then?
Yes, of course.
Yeah.
I code every day. That's my job.
Okay. I just
And
wanted-
then some of the data engineering team, when I ask them to approve my code, they give me a hard time. Then I learn. Then I don't do it again.
But Python is pretty useful with all the libraries that are in it.
Exactly. Yes, that's correct.
Can Python replace SAS as well?
Okay, you need to compare apple to apple. I'm not very familiar with SAS, but you cannot compare a programming language to an enterprise system, right? A programming language is only good as long as people are adopting it and developing models for it. Otherwise, there will be another programming language that will take over, and people will go from here to there. Like a couple of maybe decades ago, people used to like C and C++, and then AI was the language of Lisp. That was very common in AI. Then things move. But SAS is an enterprise system that has marketing power, and it has also market share. Sure.
So, like in banks, like they have some this machine learning systems where they are predicting like whether a person who is coming for a loan, whether he will repay his loan or not.
Yes.
Like I was reading some article, like they are seeing this CIBIL score of central banks and then some national banks in UAE. So
Yeah.
based on that, they are predicting like whether he will repay the loan or
Yes.
whether he will be blacklisted.
Yes.
So like how privacy will come into these things, like how banks are like providing their data for model to be trained. Like,
Banks cannot provide their data. Banks will get data from other sources like central banks, but they will not be able to share the data because of privacy and because of their own interests. So I am not quite sure if banks in the UAE are using machine learning that much to predict or to approve or disapprove loan facilities, but it all depends on history. If you don't have history, you cannot have predictive models. Simple as that. Did that answer your question?
Perhaps the banks use the model on their own data.
No, yes, banks do not have any machine language for large models. They do it manually. It's still manual.
Yes, I would perceive so, but I'm not sure. I've never worked in a bank.
Another internal kind of machine language or some
Yeah.
software where we can check their internal. Like, they can have 10 people automatically checking for a civil or maybe their internal data. But
Just follow up on that. I have my senior working in Amex Mathematics. They have a own team. So they use their own company owned data. The customer should be given like gold category, platinum category. They have their own machine learning and deep learning implementing and predicting all this thing has been happening over there.
Yes, but it might have been trained in the US, which is a completely different market.
Depending upon the like customer to customer, if they are dealing only with the Indian clients.
Yes.
US have
maybe regional.
We don't have that long history of credit rating because credit score was applied in the UAE recently. So that is maybe we'll have some limitations on what banks can do. Any more questions? Thank you very much. Finally. Thank you.
So when you have sometimes if you want to train a model but you don't have all the data, you have limited data.
Yes.
Is there a way you can train the model with limited data?
If you have limited data, it depends on what kind of limited data you have. Yeah.